Let's do another example of the chi-square test for homogeneity. As a quick reminder, there are three types of chi-square tests. The first is the chi-square test for goodness of fit. This is where we take one sample and we categorize that sample into multiple groups, and then we compare that distribution of grouping to a known or past distribution. The chi-square test for independence is where we take one sample, but then each thing in our sample is categorized twice. Maybe we ask, what's your age and what kind of pet do you prefer to own? Something like that. And then we are looking for an association between those categorizations. The chi-square test for homogeneity is where we actually take two different samples and we compare those two samples to one another. So, random samples were taken in 2019 and 2023. So notice right away we took two random samples, two independent samples. How they commute to work, and the results are in the table below. So again, we have taken our groups and we've categorized them into these four different methods. We're interested to see if there's been a shift in the way people commute to work. The appropriate test to run is the chi-square test for homogeneity. Now, the chi-square test for homogeneity, and I'm going to kind of take you through our four steps. State, I'm just going to write down, first of all, we're doing the chi-square test for homogeneity. You should always write the chi-square test, but you should also write which of the three you're doing. Our null hypothesis is going to be that the distribution of commuting methods is the same for 2019 and 2023. The alternative is that the distribution of commuting methods will be different. Or is not the same. So essentially, we'd be answering yes, we have evidence. If we end up rejecting, we have evidence that they're different. Okay, the plan step for this. Well, we actually do have two separate samples. I've added in the totals here on the top, and certainly 132 is less than or equal to 1/10 all 2019 commuters, and 146 less than or equal to 1/10 all 2023 commuters. Now, you'll remember in chi-square, we have another condition about all of our expected counts have to be greater than or equal to 5. The way we calculate our expected counts is using a formula where for each cell, we kind of do a redistribution of our amount of people proportionally into that cell. So for example, if I wanted to say, well, how many would I have expected to walk or bike? I would take the number of total people from 2019 multiplied by the total number of walking and bikers, so 132 times 57, and then I would have divided by the total number of people in my total survey, which is 278 if you take the overall total. So again, it would be the column total multiplied by the row total divided by our overall total. And I would essentially have to do that 8 times. I would come then over here and I would say, well, this column's total is 146. The row total is 57 divided by 278. Thankfully, because this is just a calculation, our calculator will do this for us when we run the test. So let's come back to this and we'll fill this in using the calculator. So let's go to the calculator and put our data in a matrix. All right, so we're going to go into our matrix. Second, in here, I've already had some matrices in here before, so I'm going to edit this one. We have got 4 rows, 2 columns, and I'm going to fill these in. 25. Exactly as they appear. I'm not going to include the totals. That's not part of it. We're just reporting the actual data. Now, once that's in, we're going to go to our Stat Tests menu. We're going to scroll down until we see chi-square. This is not the goodness of fit. It's just chi-square. The expected counts are in A. The observed counts are in A. We're going to put the expected counts in B when we run the test. We hit calculate, and our chi-square statistic and our degrees of freedom are there. Now, if we want the expected counts, which we should write down for our planned step of this, we simply go back to the matrices, and you'll see they're now filled in, but I'm going to just choose number 2, hit enter, and there are our expected counts. And we would want to copy those down onto our paper as a proof that we actually found the expected counts. So I would want to include this in my kind of expected counts. And I'm not going to rewrite it just in the interest of time here, but you would want to say something like the expected counts are all greater than or equal to 5, and you want to prove that you did it, and you'd want to put this in your plan step. But now going back to the do step of this process, I would say, well, the chi-square statistic with 3 degrees of freedom, 3 degrees of freedom, is 3.19. Our p-value is 0.36. Remember, the degrees of freedom has to do with you take the number of categories that are rows. So we had 4, you subtract 1, 3. Take the number of columns, 2, subtract 1 is 1. So it's number of columns minus 1 times the number of rows minus 1. So there's our do step. And finally, our conclude. I'll shrink all of that down so I have a little room. Conclude. We would fail to reject the null because our p-value is much bigger than any significance level, but bigger than 0.05. So we do not have evidence of a shift in commuting type or commuting preference. Okay? Because the null was that the 2 were the same. The alternative was the 2 years were different. Well, if we fail to reject the null, we're saying the 2 are the same, so we don't have evidence of a difference between those 2 years. So let's just recap this real quick. We knew it was a chi-square test for homogeneity because we had 2 separate samples that we were comparing to one another. The null for homogeneity is always that the 2 years will yield the same distribution. The alternative is that they will not. The the planned step, we had to verify that our samples were both less than or equal to 1/10 the population. I should also say, I wrote up here that these were independent samples. That's an important thing to say at some point. That's how we knew it was homogeneity, and you could certainly put that into your plan step. I'll put plan with a question mark if you wanted, but I would include that somewhere. Then we also had to figure out the expected counts. We used the calculator for that. We used the matrices to type everything in. We ran the test. Once we ran the test, we got our p-value and our chi-square statistic. We were also able to get our expected counts and copy those. I would copy those into the paper, verify they're all bigger than 5. And that then led us to our conclusion. We failed to reject because the p-value was bigger than 0.05, meaning we thought the 2 years were the same. So we don't think there's been a shift in commuting. If this video helped you, please like and subscribe for more math help.